So today I will explain Docker images from scratch, how Docker images are built, where are they stored, and the most important Docker commands you should know for working with images. As we know, Docker packages an application and its dependencies into a lightweight portable unit and run it as a container. But do you know how do you package this application, all their dependencies and its runtime environment? So to do that, we need to give some instructions like how to package your environment, dependencies, and the application. And also when they are packaged together, we also need to store them as a package. So that's where Docker image comes into picture. So what is a Docker image? So Docker image is nothing but a read-only package that contains everything needed to run an application. An image can contain all the application code, all the runtime libraries, and the dependencies. It also can contain the environment configurations which you require. It does not include your kernel or running processes or any runtime state. It includes all the stuff which your application needs to run in an isolated environment. So Docker image is nothing but an application plus dependencies and their runtime. But this Docker image actually follows something called as a layered architecture. Okay, Docker images are made of multiple layers, actually, which are stacked together. So let us take this as an example here. So at the base layer, if you see here, we have the Ubuntu or the Alpine OS layers we have at the bottom of it, and then at the next layer we can have our Java runtime environments, and top of that any other dependencies which you require, and at the end we have something called as a container layer where we package all your application, all that stuff. Okay, so this is what I mean by the layered architecture. So each layer is a read-only layers, okay, and all of them can be cached, and all of them can be shared across different images also. So how do we create each of the specific layers here? Okay, so each layer in a Docker file creates each instruction in a Docker file can create one specific layer. So I have a Docker desktop installed in my Windows machine. So if you go to something called a Docker Hub here, it contains all the images which you require for running it as a container. For example, let's say you require a Redis image, so you can find it in a Docker Hub as well. So here it is officially maintained, and you can go and pull any images of any versions here or any tags given here. Okay, so let us try to pull image here using a Docker command. So let me go to my machine here and let me try to pull a Docker Redis here. Sorry, I'm just putting the Redis image here. Now if you see, this Redis image is not locally stored. As I mentioned, it's a layered architecture. So it is trying to pull it from the Docker Hub here. And you will see now that layer by layer it tries to pull all the images here. So it is pulling from, see, layer by layer it is trying to pull all the images here. Now you could see the image has been pulled successfully from the Docker Hub, and it has been pulled layer by layer here. So let's say let's see if the images are present here. So for that you need something called the Docker images command. So this is going to show you the image which has been pulled from the Docker Hub. And let's try to pull a different version of Redis here. So let us go to the Docker Hub and let us try to pull version number 8.0. Okay, so for that you can give the same command, but here you mention the version number or the tag name here. So it is going to pull a new version of the images. Now if you see here, the difference here is, if you see, the layer was already existing, so it hasn't pulled that specific layer. Initially we pulled the Docker Redis here, so all the layers were pulled from the Docker Hub. Since some of the layers were already present, so if you try to pull the same image with a different version, so if it is built on the same layer, that layer won't be pulled again because it is cached locally. So that is what that is what actually means caching here. It's a read only, and it is cached, and it can be shared across the images. The layers also can be shared across each image. Okay, and this is a command to pull an image from a repository. So here the repository is a Docker hub, which we went. Okay, so since we have pulled an image from a repository, can we just create our own image here? So to create an own image, we need to give some instructions, and we give those instructions in a file name called as a Docker file. So it's a text file with filled with instructions. So here we give all those instructions, and each instruction is going to create a layer. For example, I have a Spring Boot application here. Okay, I have a Spring Boot application, and I've actually built the application, and I've packaged the application with this specific name. And if you see here, I have a Docker file here at this Spring Web layer, at this specific directory layer. Okay, I have the Docker file here, and the Docker file contains all the instruction here. So it is going to pull an image from this base image, and it is going to create this directory, and it is going to copy the built jar which I have done here from the target folder, and it's going to copy it in app/app/ in that specific location. It is going to store this specific image, and also mentioning that the Spring Boot application, when it starts running, right, it is going to be listening at this specific port. So when we run this image as a container, so this is the command which is going to be executed. So it is going to run a Spring Boot application with this command. So we are going to give all these instructions in a docker.file to create, first of all, create the layers, and then we have to package, or this is our application code. So we are also packaging our application code. We're also giving instruction as to on which port it should listen, and also we are giving instruction as to what to be done when an image is run as a container. Okay, so for that purpose, what we need to do here is, so since this is an example which we have mentioned, okay, so how do we run it? So this is what I've already explained, that from it is going to pull the base image, it's going to create the directory, it's going to add the application layer, and it's going to entry point is going to start the application layer. So Docker is going to catch each layer so that rebuilding is very fast. So how to build it? So we can just build it using this command, docker build. You mentioned that what is the name of the image which you want to give. Either you can give the name, or you can give the version number, and dot means that you are going to read from a Docker file, and Docker file is present in this location, the current location. So I am at this location. So if you see, I have a Docker file at this specific position. So I'll do a docker build -t. I'm going to give it a name, Spring Web Application, and Spring Web Application. I am going to read the instruction from the Docker file which is present at the current location, and the Docker file is present here. I'm going to run this. So now, right now, it is building. So if you can see here the instructions which I mentioned, right? Like you have from this base image, you have to take. So it is downloading the base image, and it is creating the work directory, and it is copying here, copying the application Spring Web jar which is there in this current directory. Now, so you can see all the instructions which I give from the Docker file are been executed step by step here. Okay, and you can see if you can check whether the images are created or not. So we can see the Spring Web image which we created using Docker file, and this is the size of that specific image which we have already created. Earlier also we pulled those images from here, right? And this is mentioning the size of that specific image here. So this is how we can create an Docker image from the Docker file, as I mentioned here. So it's going to read the instruction from the top to the bottom, and it's going to execute each instruction, and it is going to create a layer per instruction, and it is also going to cache each layer, and the order of the instructions matters. Okay, so let's say if you want to update an image also, right, we cannot go and just edit the image. Okay, you need to create a new image version. For example, let's say you want to build again. So what we can do here is we can just go back, and you have to build an image again. You can just mention a new version number, right, like this. Okay, and you can create a new image out of it. Right now I'm not doing, but this is how we can do it. Okay, so these are the common instructions which can be put in the Docker file right from the from instruction. If you want to run any command during the build process, you can use the run command. If you want to copy your executables into the image, you can use the copy command. You can set the working directory. If you want to set any environmental variables which you want, we can set using the environment. If you want to expose any your application port, on which port your application which is running should be exposed, that you can mention using the export. If you want to run your it as a container as a fixed executable, you can mention it as an entry point, or a default command which you want to run when this image is run as a container, you can mention as a command. So there are different rules for image naming and tagging, right? For example, let's say if you want to push this image into a Docker Hub, so this is how we can do it. You have to mention the repository name which you have created. So once you log into your Docker Hub, right? Let's say I have Docker Hub here, so I have created a repository here as Harish Gowda 84. So whenever you're creating an image and you want to push that image into the Docker Hub, you have to mention your repository name first, and then slash you can mention the application name, and then you can also mention the version name, for example here. Okay, you can mention the version name also here. Okay, and so let us first try to delete the images. So for deleting images, you can use a command docker rmi, and you can mention the ID here. So you can just mention your ID. So it is going to delete it. So let's say if I want to push this image into my Docker Hub. So for that purpose, I need to mention my repository name in the Docker Hub. So right now it is Harish Gowda 84, and then Spring Web. I need to ensure that I don't have that application here. So it is new. So I mentioned doc Harish 84 Spring Web, and then I mention, and then I'm creating this image now with this name. Okay. You can see the image got created. Yes, it has got created here. So let us push this. So before pushing, you need to log into your Docker Hub. Okay, and then only you can push that image. Okay, you can log into your Docker Hub, and in your Docker Hub also you should have this. You should be Docker desktop also. You should be logged in here, like this, and then only and then so okay, then only you are able to see all the images. Then only you're able to push those images. Okay, so let me just push this image first. Docker Hub to Docker Hub. So Spring Web. Okay, let me push this. So it is by default going to docker.io. Then it is going to my repository harishgowda84, and this is the name of the application, name of the image which I am pushing. Okay, so it is preparing all the stuff for pushing it to the Docker Hub. So let us wait for some time. So now you can see the image has been pushed to the Docker Hub. You can see all the layers have been pushed. Let us go to the Docker Hub and let us refresh this page. Yeah, so you can see here, Spring Web as an application has been pushed to the Docker Hub. So this is a command which I was trying to mention. You can pull any images using the Docker pull command, and also you can push any image in the Docker Hub using this specific command. And in the Docker desktop also you could see which of the images are present locally in your machine. Let's say I've created this one. So this is Spring image latest image which is there, and you can also see all the layers here which are being used for creating this specific image.